Hello, and welcome to Tech Talk with Steve, episode 49. Today we're talking about single pair Ethernet cabling, single pair Ethernet applications, and of course, single pair Ethernet testing. And I've got a guest today. I always love it when I get a guest on here. For me, it's much more enjoyable than doing this by myself. And today we are joined by Matthias Gerber, who is the market manager of LAN cabling for R&M. I ran into Matthias at Bixie show recently and thought it'd be great to go ahead and get him on here. And he's got more than 29 years of experience as a developmental engineer, project manager, product manager, and market manager in LAN cabling and RJ45 connectivity. He's also represented R&M in various standardization bodies since 1997, Senelec TC215, ISO IEC SC25 WG3, IEC SC48B, the TIA TR42 committee, and chairman of the Swiss National Committee CES TK48. Matthias also has a bachelor's degree in electrical engineering and business administration. Welcome, Matthias.
Hello, Steve. Thank you very much for having me.
It's great to have you. Great to have you. So we're here to talk about single pair Ethernet. And I got to say, I was walking through the Bixie show, and what drew me into your booth was it was the first time I'd seen something live connected to single pair Ethernet LC connectors. And I thought that was really interesting. And I thought, hey, this would be a great topic for us to discuss. So I thought I'd get you on here and allow you to talk to the audience a little bit about, what is single pair Ethernet? What's the technology? What's driving it? And what are the solutions? So I will let you go ahead and take the reins here.
Thank you very much. Yes, we have been very excited to have this display on the Bixie and be able to really have everything together. So that is fairly new for us as well. And we are thinking that SPE is really a very big thing to come. So it's one of the technologies that will drive the future. And SPE has been, let's say, hijacked a little bit by the industrial communication, the industrial Ethernet side. But I think single pair Ethernet has also its way in the smart buildings of the futures. And this is where we are basically trying to establish ourselves, to position ourselves and to position our solutions inside.
Right. Yeah, that makes sense. Yeah, we've seen it, like you said, in the industrial arena where they're replacing some of the industrial bus type cabling with single pair Ethernet. And we've seen it in the automotive industry as well.
Yeah, SPE is coming from the automotive, where it is actually already installed in most of the modern vehicles. So yes, it does have a broad base. It is a good technology, and we now see it really filtering into other industry segments as well.
Great. So go ahead and talk to us about how it's coming into our structured cabling systems for networking.
Yeah, if you look at presentation, so we are coming from a LAN background. So really, and if you look at the cabling, the LAN, we are talking about internet for people, let's say, to use a buzzword. And obviously that is a well-established technology for the past 30 years. And in the past 10 years, we really see that the whole thing starting to expand into other areas in the buildings. And one of the most obvious things is what we call the digital ceiling cabling, where we have a structured cabling for building automation, for devices from building automation, providing the same kind of thinking that we have in the LAN environment for the workspace we are now trying to establish for the IoT. And obviously that is an established technology working with a grid system. And IEEE now had the idea that at some time when everything is actually moving to the ceiling, so if all the devices of the IoT are needed to be connected, then that we will see some shortages in the service outlets that are in the ceiling. And that is actually where the idea of single pair Ethernet in the building automation came in. So single pair Ethernet is the answer of IEEE to, let's say, an overcrowding in the ceiling, in the service outlets that we have there, for the structures cabling that we are building up there. And the idea is to give a connection that has or needs less space, that allows higher density and lower costs at the end as well. If you look at technology itself, I mean, if you look at the back, we had the Ethernet that's working on 2 pairs. So the old fast Ethernet needed 1 pair for transmitting, the other pair for receiving. However, when we went up to gigabit Ethernet and 10 gig Ethernet, we are now using all the 4 pairs in the LAN cabling in parallel, meaning actually that we have 4 individual channels running on each pair. And so the idea was quite near to use similar technology for a single pair. So if we use just one part of the gigabit technology and use that to transmit different speeds in the new transmission protocol that's called 10-base T1L or S, or higher speeds. So that's something that's not new, so that's something well established. And now IEEE is actually working on 5 different protocols that run with different speeds. And we see that in here. We have the point-to-point connections that go from multi-gigabit connections, which are for very short distances only, running to the industrial protocol that goes up to 1,000 meter with 10 megabits. And this is where we are coming. Talking about that, we have to recognize single pair Ethernet is a new protocol, it's a new technology, so we can't expect really all the gadgets and things that are established from Ethernet, but that's things that are coming. And it's not the end. I mean, it's the beginning of a journey for IEEE as well. So if we look at the 2 extremes on here, to say we have 1 kilometer of transmission for 10 megabits, we have multiple gigabits for a few meters, then we can actually see what's the potential for everything in between. And looking at that, we see that at the moment, IEEE is looking into expanding the protocols of the 100 megabit up to maybe a few hundred meters, and gigabit up to around 100 meters, so that we would have similar situations as in the LAN environment. At the same time, single pair Ethernet is also having a equivalent for PoE. It's sometimes called the single pair power over Ethernet, or in standardization, it's called the POODLE, the power over data line. So this is a method to actually provide power and data on the same pair in parallel at the same time. So at the end, you only need one cable that runs from your switch to your device and provides all the power that is needed. I have to be a little bit careful because we always talk about the endpoints. So it is 1 kilometer, it's 1 gigabit, but it's not always the same time. So that is a trade-off. And the same applies here with Poodle, with remote powering, because the higher the power that we are providing, the shorter the link has to be. So there is a trade-off that you see on this table on here. But basically, with a 20 watts power transmission, you are able to reach up to about 200 to 500 meters, depending on the cable size that you are using. Yeah, having said that, the connectivity is by far not at the end as well. So we have multiple proposals in standardization that are standardized in parallel. And at the moment, all these different styles are competing for awareness, or competing to be selected in specific use cases and applications. R&M itself is concentrating on the two standards, or the two interface styles, which are the IEC 63171-1 and the 63171-2. So these are the two connectivities where we are looking into. The other connectors, they are very much used in the industrial environment, very often with higher IP protection, so against water ingress. And this is typically what you would see in an industrial Ethernet application. What is SP used for? So there are actually two goals. So, and the main goal for SPE is to actually aim against the different field bus systems that we see currently, and to bring in an IP protocol that is able to replace the different field bus systems. SPE is giving all the safety security features of IP, which many of these field bus systems don't have. It also, even though it's in a LAN environment, it's quite slow with 10 megabits, but in the area of building automation, 10 megabits is big and is enabling quite a few new features into the devices. For example, the possibility to have software downloads online while connected, and not having to do everything by moving around with your laptop and configuring your devices anew. The other part is, of course, also the possibility to replace Ethernet. Even though I personally don't think that it will replace Ethernet in broad applications. So it is not a new LAN application. I think it is an addition for certain niches, for certain applications where it can actually play with the benefits that single pair Ethernet provides. These are namely the farther reach. So everything that's beyond 100 meters in coupled communication would need or could go to single pair Ethernet. But also higher density. So if you see all the devices in a building that goes onto the IP network, it's sometimes that an RJ45 is simply too big. It's mainly connectivity and a little bit of electronics, and this factor is a little bit improved if you use a much smaller single pair Ethernet connector on there. And also in installation gives some benefits by just being smaller, because having just one pair is obviously 1/4 of 4 pairs. So it is better with fire load, all of that things that come into protection against fires, but weights, about density in conduits, all these kind of things could the single pair Ethernet could benefit. Well, having said all that, single pair Ethernet is still something that is in the future. And this is where this display came in, or this demonstrator came in that we showed on the Big C. So what I'm tried to do with a partner from the Single Pair System Alliance is to come up with a complete system that can be used in the LAN environment. And this is what Steve actually saw at a Big C, and where we actually got into the conversation a bit. Maybe let's have a short look on how that looks like. What we see here is this demonstrator. So basically what we choose to do is using a normal IP camera as a representative of a legacy Ethernet device, which is powered by PoE. We'll see that on here. So we just have one PoE connection going into it. So the whole thing is powered by the media converter that we have. So as I mentioned, single pair Ethernet is able to use or cover distances that are far beyond 100 meters, the normal limit for Ethernet. So this is an application which is for exceptional cases where you need to cover bigger distances. What we have on one side is a single pair Ethernet switch, which converts the Ethernet protocol RJ45 into single pair Ethernet. And then we use the distance from the floor distributor out to the device with up to 200 to 500 meters to a media converter. Now, the media converter is not what we would use for eternity. So it is a kind of a temporary solution while we want to use legacy equipment. But the media converter then will convert back the SP signal into an RJ45, and the RJ45 goes back to the camera. So what we see on here on the laptop is connected to the switch. The camera is connected to the media converter. Now the media converter, as you see, has a local power supply. So with a local power supply, you can do everything above 600 meters. We used it in this configuration also up to 1 kilometer, but that's beyond standard performance. But you also can just unplug power of the media converter, and now the whole system is powered from the switch. So the power goes from the switch through the whole of the cable, 300 meters of cable in this case, powers the media converter, and the media converter itself powers the camera via PoE. So there's one SPE cable that will power the whole application.
That's impressive.
And yes, I mean, for us, it is a way how we could cover the gap between the availability of the products, of the cabling products that we have right now, and the availability of devices, applications.
Yeah,
because
that makes absolute sense because you've got these legacy devices that you were saying that run on 10 base T, and if you want to utilize that single pair Ethernet cabling, you can actually deploy single pair Ethernet cabling and still use those legacy devices, and then you get to remove those lower bandwidth legacy devices from your main network, so you free up bandwidth on your main network. It makes a lot of sense.
Yeah, absolutely. And I mean, the main problem we had in the past 2 years, also in the Single Pair System Alliance, is that everybody was waiting for everybody else. So that is now the cabling guys waited for the devices to come up. The device guys and application guys waited for a cable to be available. And therefore, that for us, it's really the way to overcome that. So to let's say cut the Gordian knot that we have on here, and come up with a agreed niche application, but something that is reality, that's something that can be used today, and that actually starts to use SB and brings it into the industry.
That makes absolute sense. Before we jump into testing, I believe you've got a portfolio of products. Can you talk to us a little bit about the products you've got that are currently available for these applications?
Yes, happy to do. Just a few words about this application itself. So basically where we see it mainly is in let's say remote applications, like a camera that's somewhere on a parking space, whatever, an access point, a door, a gate control that runs on IP, a big warehouse where you want to use IP devices and don't want to use multiple floor distributors. So that is the application where we see it right now. The portfolio itself, yes, it's something that we have on here. So as mentioned, we are focusing on the 63171-1, which is the interface that has been recommended by SC25, by TIA, and by IEEE. So that is the interface that people or that the standardization committees choose for a single pair Ethernet application in the building environment. And we see it here on screen, but we can also maybe have a look on it in reality. We have on this side the connection module, which will terminate installation cable. And on this side, we see this is a duplex module, so that shows that we can actually double the port density in the normal RJ45 cutout. Obviously, also we have patch cords. These are fully industrialized, tooled up products, and they are available from stock. So that is a patch cord in the so-called LC copper style, and the installation cable we see here. So we have an example of a Y-gauge 22 installation cable, fully screened, so it is also suitable for a heavier industrialized environment, and that is what we currently have in standardization. Obviously, we'll have the two products for the active components. So we have that's the part. That is the switch, where we have a RJ45 to 4 single pair Ethernet switch with poodle supply, and we have the media converter, where we simply have one single pair Ethernet connection going back to RJ45, and this is a PoE port. So these are the products that we are offering. The whole connectivity part, the cabling is available from stock. The active components, we are in the final stages of getting all the approvals that are necessary. So they will be available in summertime.
Great, great, fantastic. So there's a lot of good information there on, that you've given us on SPE and the products. So I want to talk a little bit about testing. I'm going to go ahead and let me share my screen. And we keep switching. This camera keeps changing on me. That's not a great view. So I'm going to pop up a couple of slides here just real quick, and then we're going to do a quick demonstration. So we've installed single pair Ethernet cabling. We're going to have to test it, just like everything else. There are some differences. SPE cabling standard specifies 1,000 meters, but your test equipment is going to need to go longer than that. They're going to be expecting test equipment to go at least to 1,500 meters, possibly more. And they both need to be able to communicate over that long cable under test. Frequencies are different. This is going to be a lower range of frequencies. We're going down to 0.1 megahertz, whereas for 4-pair cabling, we're bottoming out at 1 megahertz. Additionally, there's a finer frequency resolution. What that means is it's more tests along that spectrum of frequency. And the part on the top here, you can see that there's a lot more lines here. That essentially means we're testing at a lot more points along that frequency range. So more intense tests. And there's also fewer parameters here. We're just looking at insertion loss, return loss, TCL for unshielded, DC loop resistance, and delay. Shield continuity measurement when you're doing the shield cabling, and DC loop resistance are measured. DC resistance on balance can only be tested on a shielded cable. When it comes to power over the cabling, that resistance on balance is not as critical because, again, you're only using a single pair. It's not like when you have 4 pairs and you start to get that unbalance and it starts to create some really big problems for power. It's much more simplified with single pair. This is just a quick example of a test. I'm going to show you a live test here in a second. Your testers are going to be available for single pair Ethernet depending on who you're using for your test equipment. Like us, our existing cable certifiers just require a new test adapter. Other testers may require you to purchase something separate to do single pair Ethernet. So consult your test equipment manufacturer when it comes to that. So I'm going to do a quick demo here. And Matthias was kind enough to send me a sample channel here. And you can see what he was talking about, the density. There's 2 single pair Ethernet jacks right there. And of course, it's just looped behind here. And then that's an RJ45. So you can see it does fit that same footprint. And I've got test adapters here. Everybody's used to seeing the RJ45 channel adapter. I'm going to show you with the single pair Ethernet channel adapter. I'm just going to pop it into my Test Pro remote here. And that's going to go ahead and recognize the adapter. I've got my Test Pro main over here on the right. I've already got a patch cord set in this. I'm going to go ahead and take this cord and I'm going to connect it into one of the 2 ports. And I'm going to plug patch cord into my remote. So I'm going to grab that remote cord and plug it into the plate in a moment. In your setup, I've already set my project up, but if you're used to using our Test Pro, you'll just go into your test profile. And you'll set up a project like you would any other. You'll set it up with a limit for single pair Ethernet. And then you can choose your cable or you can create a custom cable. I input a custom cable here with a special NVP value that I'm using. But when you plug your adapter in, it's going to sense that you've put an SPE adapter in. So you'll have that recognized immediately. So it will default to an SPE test. So I'm going to go ahead and take the other end of my patch cord. And so what we're seeing here, that's my remote. What you're seeing on my screen here to the left of the camera view is the screen from my Test Pro main. So I'm going to plug in the cord coming from my remote. And just like with 4-pair, we get a live wire map. So right away, we know if our wire map is good for our SPE. And I just have to click auto test. And we're going to go ahead and run a test of this channel for single pair Ethernet. And once it's completed, we're going to go ahead and see the results. And here we see we've got length. We've got a little over 11 meters in length here. We've got DC resistance. Everything looks good. We see our wire map. So these little indicators here are just telling me that there's a slight difference in the shield between my installed cabling, my loop back here, and the patch cord. So just a slight difference in the type of shield that those have. And that shows up. It's not going to fail the test. It's just an indicator letting you know. And then here we see we've got our length, we've got our delay, DC resistance, insertion loss, return loss, TCL. We can look at our plots, just like we would in a 4-pair test. We can see our DC resistance. We can go in and look at our return loss. So all of our plots in here, we can see. We also have our return loss locator and our shield locator. So if you had a return loss failure, you could plot along that where that is. And your shield locator, if you have a shield problem, you can go in there. It's just a TDR trace. It'll show you where that problem is along the cable, just like with 4-pair. So all those same features are available when you're running the test with the SPE adapters. And again, it's just a matter of putting that adapter into the tester. There's no additional software license, no additional firmware needed. It's already built into the tester. You just have to get the adapter. And you save the test just like you would any other test. And then when you save your test results, you'll upload them to the PC software, Test Data Pro software, either the cloud or the PC-based version. And you'll have to have test results when you're testing cables to provide proof that the cabling was installed and that it's performing correctly. And this is an example of that single pair Ethernet test result. So that gives you a good example of all of those, the things that you need to keep in mind with single pair Ethernet, just like 4-pair cabling. The fact that it's doing tests at different frequencies, you don't have to worry about that. The tester knows. You're going to be following the same procedure you're testing with 4-pair, just using a different test limit. So it's pretty basic. So I'm going to go back on camera now. And see, we've got a couple of questions. Oh, one question. Oh, it's not single pair Ethernet related. AEM precision cable test. Is there a fiber optical SFP supported? Thanks, Mohammed Khalid, for your question. We do not currently support fiber SFP, but stay tuned. We're always coming out with new stuff. There is an SPE question. Are there any SPE permanent link adapters available with AEM? No, SPE is specified as channel testing right now. So it's not really done with permanent link. No other questions that I see there. Matthias, anything else you wanted to mention before we wrap up today?
Not really. I'm really pleasantly surprised on the quality of your tests there, and I'm quite happy that now the things are coming together as well, because yeah, testing has been indeed one of the problems that we had in the rollout of the whole thing. So to actually now everything seems to be available, and there is nothing really preventing us to go into single pair Ethernet now.
Yeah, I agree. It's just a matter of that technology catching up to start driving everything. And we talk about it all the time when I'm talking about smart buildings. We're talking about how to assure the infrastructure readiness in a smart building. We always mention single pair Ethernet as a way that users can offload for those IoT devices that are taking up bandwidth on the main network. They can be offloaded and segregated on a single pair Ethernet network and free up bandwidth for other things. So it's coming. It's we've been talking about it for a year or two now at least, and I think we're getting close to where we're going to start seeing this coming in smart building installations. I would imagine probably over the next 12 to 16 months, we're probably going to start seeing some of this being specified in new smart building installations.
Let's hope for that, yes. And even those industrial segment seems to be a little bit ahead, I'm positive that single-pay Ethernet will find its way also in the building environment.
Gotcha. Here's a question that came up for you, Matthias. Is R&M providing a system warranty of 25 years on the SPE end-to-end links?
That's a good one, because that's known from the RG45. Yes, actually there is no difference between technology in a single-pay Ethernet. We use same existing technologies that we use in RG45, so there is no reason why we shouldn't go into a system warranty as well.
Just requires a certification test, just like everything else. Yep.
Yes, you catch that one. Yes.
Yes, absolutely. Great. All right. Well, that puts us at the well, a little over 30 minutes. So that was good. A lot of great information, Matthias. I appreciate you joining us today. This was a good episode. And any closing remarks?
No, I think that is a great platform you build up here, and that I enjoyed being on the show. Thank you very much.
Thanks. It's been our pleasure. And thanks everybody who attended. And we look forward to seeing you again on the next episode in a couple of weeks. Thank you very much.
See you. Goodbye.